But friends, I think you are getting the concepts, you are understanding the subject, and I hope that you are doing homework, whatever I am giving in the classes. Friends, your success will be directly proportional to the problems you are solving at your home. So please, if you want to become conceptually strong in the subject, please do as many as problem as you can. Okay friends, you can prefer the book Alexander and Sudoku Electrical Circuit for the high level problems, standard problems, gate level problems. So here we go. Here we are starting with this problem. In the figure, the current I1 is. Where is the I1? Here is the I1. He is asking for the I1, not I2. Okay. So it's very simple, right? Why this question is very simple? Because, see, everything is given here. Two meshes are here in the circuit. Okay, fine. Two nodes are there. Okay, fine. One node will be grounded. Okay, fine. Only one node will be remain. It means to solve this circuit by node analysis will be easy than mesh analysis. Is it okay? I'm assuming this node A. I'm assigning the voltage to this node VA. Now I'll write the nodal analysis on A. I'll write nodal analysis at point A. Is it okay to you? Now, okay. Three branches are connected, means three currents you are having. Is it okay? The first current is this. VA minus 20, VA minus 20 minus 0 divided by 2 plus 3. Is it okay? VA minus 20 minus 0, this 0 is to the ground. We'll start from the VA, we'll go to the ground, okay? And the resistances we are getting 2 and 3, they are in series in the whole circuit. While going from VA to 0 ground, we are getting 2 and 3 in series circuit, series combination. So 2 and 3, this 5. Next, why I'm getting this sign is the positive. Why? Because the current is outgoing. Why the current is outgoing? Why? Because this VA is the at higher potential. This is my assumption. Whatever node I'll assume, so the voltage at that particular node will be at higher potential than any other existing voltages in the circuit. Okay, fine. What about this? In this branch 2 ampere is coming already. For the upcoming current, negative sign, 2 ampere is the value. Fine. Next, this branch VA minus 0, VA minus 0 divided by 1 plus 4, it's 5 again, equal to 0. Only one unknown, one equation. You can take 5 LCM, VA minus 20. This is the minus sign, 10 plus again VA equal to 0. VA, 2 VA equal to 30. Finally, VA equal to 15 volt. Once you find out this VA value, 15 volt, anything you can find in the circuit now. You can find out the I1 and I2 as well. Okay, what is the value of I1? Here they are giving the direction already, that I1 is the clockwise directed current. Okay, so this is nothing but I1, is it okay? But here in this case direction is the outgoing, actual current is the incoming current. Okay, leave it. See, we'll start from here because this current is coming from the ground, suppose. Why? Because the direction is the clockwise. We'll start from the 0. We'll in this circuit we can apply the KVL in this circuit to find out the value of I1. Here the voltage drop is 2I1. Fine. I'm writing the equation minus 2I1. Why minus? Because I'm terminating at minus. Here this voltage is VA. This voltage VA is the voltage across this. This voltage VA is nothing but this voltage. Okay. So I'm getting minus VA. VA is 15. You find out already. Come here. Again plus minus 3I1. Okay. Plus 20 you are getting equal to 0. Minus 2I1, minus 3I1, minus 5I1. Am I correct? Minus 15 plus it is 5 equal to 0. Finally I1 equal to, tell me. I1 equal to 1 ampere. This is the positive current, means direction is the perfect. Yes, this is the answer of the circuit. It's very simple problem based on nodal analysis. See, a very beautiful problem is waiting for you now here. Calculate V0, I1, I4 in the circuit. Where is the V0? Here. Now suppose someone is thinking that you will apply the mesh analysis in this circuit. So you are thinking wrong. Why? How many meshes are there in this single circuit? 1, 2, 3, 4, 5. 5 meshes. How many meshes? 5. 5 meshes means 5 equation. Means 5 unknown. So will you solve for this? Even your calculator is not able to solve this equation, and nowadays calculator is not allowed in the examination. So friends, here nodal analysis will be very easy to apply, and now few minutes we'll get the answer. See, only 2 nodes are there. This all points are a single point. Why? Because they are short circuited. There is no element in between them. So these points are the single point. And second node is this, already grounded, only V node is there. Here at the V node I'll apply the node analysis. Node analysis at node A. This is the node A, suppose. Okay, fine. So how many branches are connected over there? 1, 2, 3, 4, 5, 6. 6 branches are connected at this node. It means 6 terms will be there in a single equation. I'll start from the first branch. Incoming current. Yes, I'm writing the current equation. -8 is the coming current. -8. Okay, fine. What about this? Here the voltage is V0. Here is the voltage is 0. The going current is nothing but V0 minus 0 divided by 10. Next, V0 minus 0 divided by 20. V0 by 20 I can write this. Next come to 30. V0 divided by 30. Next, plus 20 is outgoing current. Plus 20. That's why I'm writing plus, because this is the outgoing current. Come to the next. Next is nothing but V0 by 60. Is there any problem? Equal to 0. Okay, this is first branch, this is second branch, third branch, fourth branch, fifth branch, and sixth branch. You can take LCM 60. It is -8 into 60 plus 6 V0 plus 3 V0 plus 2 V0 plus 20 into 60 plus V0 alone equal to 0. How many V0 we have? 6, 3, 9, 11 and 12. 12 V0. 12 V0. This -20 into 60 will go this side into 60. And this will come this side, 8 into 60. So finally 60 will come out into -12. Here 12 V0, sorry, 12 will cancel out. V0 equal to 60. Is it okay to you people? This is nothing but the answer. It's coming -60. Okay, -60. It's -60. So the value of V0 is nothing but the -60 volt. Now anything you can find out. Either it's I1 or I4 or anything. Is it okay? Very easy question. Come to the next one now. See, this is the problem. Obtain V1 and V2 here. Again, you can solve this circuit by nodal analysis. But I'll do this for, okay, V1, V2. I'll do this circuit by source transformation theorem. Okay, I'll take it here. See, I'm doing this problem by source transformation, and there is a condition for source transformation. Whenever you transform the sources like current into voltage or voltage into current, you have to keep one condition in mind, and that is the point should not be changed. Points means the points of consideration, whatever point. Here 2 points are in consideration, V1 and V2. Why? Because they are asking for the V1 and V2. So the state of V1 and V2 should not change. Okay, fine. Here 5 and 10, they are connected in parallel combination. So the resultant is 50 divided by 15. Is it okay to you people? Now come here. This is the current connected parallel with 4, and I can convert this in a single voltage source like this. We have seen the source transformation in which we converted or transformed the current source into voltage source and voltage source into the current source. Here current source is given, and you know the condition of current source. Current source will be always connected in parallel with the resistance, and the voltage source will be connected in series with the source, okay, resistance. So what is the value of this V? V equal to Ri. I is given 3, R is 4, so this is 12. Fine. What about this resistance? This is nothing but 4. Here also I can again apply the source transformation. Okay, I'll apply the source. This is the resistance and this is the battery sign. See the polarity of the battery. Battery polarity is the higher potential is this side, lower potential is this side. Why this? Why not the opposite of this? Because I know the current direction. Current is going from this side to this side, and this is possible only when the polarity of the battery is like this, because it will deliver the current. It will deliver the current. The directions are same. That's why I'm taking this polarity. What is the value of this voltage? 66 into 2. This is 12, and this is 2. Okay. This is the simplified circuit. Now you can find out the current in the circuit. Once you find out the current in the circuit, you can get any value, V1, V2, power drop or whatever. So we'll see the we'll find the I1. Apply KVL in the circuit. We'll start from here. This is the voltage drop, 2I. So I'll start 2I. Fine. I'll move forward. I'm getting 12 plus 12. Why? Because at the terminating point is at high potential. Come here. V2 is the point voltage. Come here. This is 4. So, sorry, it is minus 4I. Because here also the drop is same. Here minus 12 you are getting. Come this side, this side, this side. Here you are getting 50 by 15I. 50 by 15I equal to 0. This 12 get cancel out. Finally I equal to 0. There is no current in the circuit. In this situation you don't have any current in the circuit. What you will do, tell me. There is no current in the circuit. Now we'll find out the V1 and V2. Okay. Let me remove this. Okay, fine. The current is 0 over here. Okay. Okay. The current is 0 ampere. So current is 0 ampere means there is no drop across any resistance over here. Here the drop is 0. Here the drop is 0. Here the drop is 0. Okay. Now what is the V2? This V2 is the voltage of this point. And we discuss about this. Any voltage given in the circuit with reference to ground. So this is nothing but this entire thing is nothing but V2 actually. So the voltage of this branch is nothing but the V2. The voltage in this branch is, tell me, 4 into 0 plus 12 equal to 0. So 12 volt is nothing but V2. Is it okay to you people? If you are getting any confusion here, I'll do it again for you. See, simply for this circuit you can apply the KVL over here also. Let me change the pen color. I'm taking red one. Okay, fine. See, suppose this is the entire closed circuit. This is nothing but the V2. Sorry, this is not closed circuit. This is the battery V2 over here. So we'll start on the circuit analysis from here. Come here, we are getting minus V2. Fine, minus V2. I'm coming minus V2 going to plus 12. Okay, fine. Here I'm getting plus 4 into 0 equal to 0. This will go out. V2 equal to 12. Is it fine? What about the voltage? V1 is the voltage across this point, and V1 is given with reference to ground voltage. And we know the voltage drop in this branch is nothing but 0. Why? Because the current is 0. So 50 into 15 into 0 is nothing but 0 volt. So the answer of this circuit is V1 equal to 0, V2 equal to 12. If you will do this circuit by the KCL, it will take longer time than this. Okay. Come to this circuit now. Very easy circuit. I'm leaving in this for you. This is the dependent source circuit. Easily you can find out the value of this current. Okay. Any problem? Come to the next one. This is the again dependent source problem. Will you do or I will do for you? Okay. I'm doing this for you. So I'm taking this problem on a phrased page. Okay, fine. The problem given is, this is nothing but 20 ohm connected with 40 volt battery. Fine. Next, this is given 20 ohm. In this 20 ohm, Ix is given. Ix connected with 10 ohm. This 10 ohm again connected with 4Ix incoming current, where Ix is nothing but this only. So here also I should write like this. Okay, fine. Come to the remaining part of the circuit, and that is 10 ohm resistance, and the voltage, this is the 10 ohm resistance, and voltage across this is nothing but V0. Now the question is, find out the V0. Find out the V0. Okay, is it clear to you? Now come to the circuit analysis. First we'll smash the circuit. Smash means whatever information available, apply that first. Ix is going to this side, means the voltage drop across this is nothing but 20 Ix. Tell me any problem. Ohm's law, simple Ohm's law I am applying here. Current into resistance is nothing but the voltage. So here the voltage drop is 20 Ix. So this is voltage is nothing but the voltage across this point, 20 Ix. Any problem? Tell me. Whatever voltage across this resistance is given, the same voltage is of this point. Okay, because the voltage across any point in the circuit is given with reference to the ground. So this is the 20 Ix, and this is another voltage, and this voltage is directly given V0. Why? Because this is the voltage, right, across this point, right? See, this is the ground, right? So V0 is the voltage of this point, because this V0 is given with reference to the ground. Okay, I hope it's clear to you people. Now see, we are having two nodes. We can apply KCL or not. First apply the KCL at node A. Suppose we are having A and B. So node analysis. Node analysis at A. Okay. So apply the node analysis here. What is the voltage? 20 Ix. This is the voltage here. Minus 40. Divide by 20. Okay, fine. What about this? Ix is outgoing current. Take it directly. Ix outgoing current given directly. You can take 20 Ix by 20. Again you are getting Ix only. Now 20 Ix minus V0. 20 Ix minus V0 divided by 10. Is there any other branch? No. 3 branches are connected at node A. So I'll be having 3 terms in one equation equal to 0. Fine. This is the equation 1. Now come to the second equation. Second equation will be coming from the second node. Now node analysis at node B. Come to the B now. V0. 3 branches again. 1, 2, 3. V0 minus 20 Ix. V0 minus 20 Ix divided by 10. Fine. Come. This is the incoming current. Minus 4 Ix is the value. Minus 4 Ix is the value. Now V0 minus 0 divided by 10. V0 by 10 equal to 0. Equation 2. Now if you will observe these two equations, you are getting that we are having two variables, Ix and V0. Two variables, two equations. You can easily solve these equations. So at the end you will get output V0 equal to 60 volt and Ix equal to 2 ampere. These are your answers. Okay, you can cross check it by solving these two equations by your own. Fine. Come to the next one now. What is this is for you, homework. This is homework to you. Okay, very easy question. This one is also very easy question. Here you can apply source transformation if you want. But remember that V0 should not be changed. Where is the V0? Here is the V0. V0 is the voltage given across 4 ohm resistance. This condition should not change. So transformation says that you have a restriction that the point where you want to get something, don't change that point. Okay. Is it okay to you? Come to this question now. Find out the V naught. Where is the V naught? Here is the V naught. Okay. So I'll draw this circuit for you on the phrase page or here. Okay, we'll take here only. Assume the node voltages. Node analysis will be okay for this. Here take V1, this one V2, this is V3, this is V4. There are so many nodes are there. So 4 equations will be there. So it will be very typical to solve this, right? But if you will clearly observe this, so we'll see if we are going to apply here the node analysis at V1, 3 branches we are getting. 1, 2, 3. Is it okay? So from this branch there is a no variable we are getting. Directly we are getting the current. So in this equation, while forming this, we are getting 2 variables, V1 and V4. Is it correct? Similarly, when we are form the equation at V4, here we'll get 2 unknowns, 2 variables. One is V4, another is V1. There is a no variable coming from this branch, means V3 or V2. Why? Because 2 is incoming current. So directly we can write the current value. See, what I'm saying is, we'll apply the node analysis at 1. So you'll see what I'm saying. Nodal analysis at node 1. Okay. Here. Tell me the equation. V1, fine. This is 0. Divide by 1 resistance. Minus 4 incoming current. Minus 4, fine. V1 minus V4. V1 minus V4 divide by 8. Is it okay? Equal to 0. We can simplify this. Take LCM 8. This is 8V1 minus 32 plus V1 minus V4 equal to 0. Again we can simplify 9V1 minus V4 equal to 32. This is equation 1. Now come to the V4 now. Directly come to the V4. Don't write the KCL equation for this circuit. Why? Because we want V naught and we are getting the V naught by applying the nodal analysis on these 2 nodes only. So V4 divided by 1 minus 2 is the incoming current. V4 minus V1, V4 minus V1 divided by 8 equal to 0. See, 2 equation, 2 unknown only, V1 and V4. And once you are able to find out the V1 and V4, you can easily find out the V naught, because V naught is nothing but what? V1 minus V4. See, the polarity, this is V naught given in the circuit. Means the potential difference between these 2 points. Here the voltage is V1, here if the voltage is V4. V1 minus V4 nothing but V naught. I hope it's clear to you people. Again you'll take the LCM. It will be 8V4 minus 16 plus V4 minus V1 equal to 0. Finally, for this you'll get 9V4 minus V1 equal to 16, equation 2. When we'll solve these 2 equations, we'll get V1 equal to 19 by 5, V4 equal to 11 by 5. Now our V naught is 19 by 5 minus 11 by 5 equal to 8 by 5 equal to 1.6 volt. This is our answer. Okay, this one is very clear. I hope this one is also clear to you. Can you do it for me? Find V naught and I naught. Where is the V naught? Here is the V naught. Where is the I naught? Here is the I naught. I think you can do it, so I'm leaving this for you. Come here, very interesting. Find out I naught. This is the bridge type of circuit, and he's asking for I naught. Here is the I naught. Okay, so in this circuit they are asking for the current I naught. Is it okay? So if you are able to simplify this circuit like this. This is 56 volt is there. Okay, fine. This is 2K is there. And instead of this whole circuit, suppose you are having equivalent of this circuit, R equivalent. So it become very easy to find out I by K, Ohm's law. I is nothing but V by R. So this I is nothing but V by R. R is nothing but 2K plus R equivalent. Is it okay? They are in series, 2K and the R equivalent, they are in series. So I am adding these two terms, 2K and R equivalent. Where V is this 56. 56, 2K plus R equivalent, and this I is nothing but your I naught. Now, task is to identify the R equivalent here. Now, our new task is to find out the R equivalent. Okay, so we will solve this circuit for R equivalent only. As I told you here, the 6, 4, 2, 4, 6, they are not connected in series or parallel connection. They are in delta and star connection. See this 2, 4 and 4, they are connected in delta. We can easily convert this 3 into star. Can I? Yes, you know the formula also. Okay, so your new circuit is like 2K I'm drawing your new circuit now. Okay, 6K, 6K, these 2 points like this and like this. This is your ending point. Is it okay? Now tell me the value. The value of this is nothing but 4 into 2, 8 divided by summation of all 4, 4, 8 and 10. Is it okay? 4, 4, 8 and 10. So 8 by 10. So this is nothing but 0.8K. Is it okay? Come to this. Again 4 2s are 8. So this is again 4 into 8. This is 1.6K. 1.6K. I hope it is clear to you people. Now the circuit is resolved. See, the 6K and 0.8K, they are in series. So you can replace this branch by a single element. And that element will be 6.8. Is it okay? Your new circuit I'm writing 2K. Fine. This branch is 6.8K. And the parallel with 6.8. This one is also 6.8K. And here 1.6K. This 6.8 and 6.8 connected in parallel. So the resultant will be, so the new circuit will be, this is 2K. The resultant of this 2 will be 3.4K. And this is 1.6K. And this is over. Okay. Now 3.4, 1.6, they are connected in series combination. This is 2K. This is nothing but 5K. Is it okay? 2K, 5K, they are connected in series and the total is 7K. So finally your current I naught is nothing but 56 divided by 7K. So this is 8 milliampere. Is it okay? As simple as that. So this is the last one of the chapter and I'll do it for you. Okay. First I'll remove all. I'll erase things. Okay. Now come here. They're asking for the Ix and the Vx. Where is the Ix? This is the Ix. Who is depending on this Ix? This source is depending on this Ix. Where is the Vx? Here is the Vx. And who is depending to this Vx? This current source is C. Now we'll smash this circuit. We'll do the micro analysis of this circuit. 3 ampere. Fine. Yeah, Vx by 4. Vx by 4. Fine. Here the voltage drop is Vx. Is it okay? So friends, at this node, two currents are leaving, Vx by 4 and 3. Means here the incoming current is equal to the outgoing currents. So in this branch, the current is the summation of these two currents. Is it okay or not? Tell me first. In this branch, the current will be 3 plus Vx by 4, is it? Right? So the branch current is 3 plus Vx by 4. This is the branch current. And branch resistance is 2. Is equal to V, na? And the voltage across this is Vx. Directly given. One unknown, one equation. Okay, we'll find out. 12 plus Vx divided by 4 into 2 equal to Vx. 2 ja. So finally, the value of Vx is, here I am writing 12 plus Vx equal to 2Vx. So Vx equal to 12 volt. So I get the first one. Vx is nothing but 12 volt. Now we have to find out the Ix also. Okay. We'll find out the Ix. First I'll erase this. Okay. Now for Ix, what should we do? Tell me. We'll assume voltage V here. Okay. I assume the voltage V. Here I'll apply the nodal analysis. So I'm writing the nodal analysis at this node. Here this is the voltage V. Same. Okay. V minus 50 divided by V minus 50 divided by 10. Fine. Next. 3 ampere is coming. Yes, 3 ampere is coming. Okay, we already find out the value of this Vx, that was 12. So this is nothing but 3. Minus 3 is coming over here. Okay. And remaining branch is this branch. So plus V minus 4Ix divided by 5. Is it clear to you? Good. LCM is 10. So this is V minus 50 minus 336 60 plus 2V minus 8Ix equal to 0. So finally you are having 3V minus 110 minus 8Ix equal to 0. 3V minus 8Ix equal to 110. Equation 1. Okay. So one equation is this, and two unknowns. One equation we can't solve. We need another equation. So see this Ix. What is the Ix? This 50 minus V divided by 10 or not? 50 minus V divided by 10. This is nothing but Ix. Is it okay? So V here V is 10Ix equal to 50 minus V. So V equal to 50 minus 10Ix. So I'll replace in this equation the value of V. 350 minus 10Ix minus 8Ix equal to 110. Is it okay? So this is 150 minus 30Ix minus 8Ix equal to 110. I'm writing over here. So minus 38Ix equal to 110 minus 150. So this is 40 difference. Minus 38Ix equal to minus 40. Will cancel out. Ix is 40 divided by 38 ampere. This is answer. Like this we have to solve the circuit. This is all about the first unit. I hope you get the concept how to solve the circuit. Okay. So this is about the first unit. We have finished. We have covered all formulas, all related to this basic concept and all. Now we are going to start the second unit, that is the circuit theorems. So actually what is the circuit theorem? See friends, In the network analysis or electrical circuit, the basic laws are the KCL and the KVL. KCL and KVL say how to solve the circuit, how to find out the current or voltage in the various branches or the elements of the circuit. Okay, so in this first unit, we are having one circuit. We are getting the original circuit and we are applying the KCL and KVL over there on the circuit, and at the output we are getting current and voltage in the respective branches. But in the second unit, by the use of circuit theorems, first we will simplify the circuit, or in the simplified way we can find out the voltage and current. The same thing we are going to do. We have to find out the current and voltage only. We have to apply the KCL and KVL only in theorems also. But theorems are dealing with the circuit only. See what I'm saying there. In the first chapter, we were having the simple circuits. In that particular circuit, we were applying KCL and KVL and finding out the output current and voltages. Now, in the theorem, in this second chapter, we'll be having a network or electrical circuit. First we'll simplify the circuit, then we will apply the KCL and KVL, and then we'll get the output. So this is the basic behind the theorems. So we are having 4 to 5 types of theorem. We'll start with the superposition theorem. We'll see the Thevenin theorem, Norton theorem, substitution theorem, Millivans theorem, reciprocity theorem. Okay friends. So here we go. We'll start the second chapter, and that is the circuit theorem. So here we go. We are starting circuit theorems. Okay. And the preface of this is, again I'm telling you what is the circuit theorem, why we are applying and where we are applying. See, circuit theorem. This is the second chapter name. See friends, in the first unit we have seen, suppose we are having circuit, simple circuit, having two sources, like this. This is the current source, this is the voltage source. The different values of resistances R1, R2 and R3. And suppose there in the first chapter they are saying that find out the current in this, find out the voltage across R2, like this. So we were applying simply nodal analysis or mesh analysis. Here in the circuit theorems also, the tools are same. The analyzing tools, KCL and KVL, are same, but we are not taking into consideration the original network. This is the original network. We will simplify this network now. Or we will apply some methods to solve this circuit, and then we will get the current. Okay, so this is the significance of circuit theorem. Okay, you will understand. We will start it. The circuit theorems, course outline of the electrical circuit, in which we will see the superposition theorem, Thevenin theorem, Norton theorem, reciprocity theorem, substitution theorem and Millivans theorem. And most importantly, we will see the maximum power transfer theorem. Okay. Come now, the learning objectives. We will understand the theorems. We will see the superposition theorem. Then we will see Thevenin, Norton, substitution, reciprocity and MPTT, maximum power transfer theorem. In this entire unit, we will solve some gate problems also, and this is the very, very important subject. Okay, unit, chapter. See, we are having total 4 units. 1, 2, 3 and 4. So as per the gate is concerned, the weightage of this is 30%, 20%. What about this? 30%, and this is 20%. So this second unit is the very important. Okay. So here we go. We'll start with the superposition theorem first. Here is the introduction of the circuit theorem. A major advantage of the analyzing circuits using Kirchhoff's law we did in the first chapter is that we can analyze the circuit without tampering with its original condition. As I told you in the introduction, that we'll consider the original circuit, whatever we are given with. Okay. But in the circuit theorem, when we are going to apply the circuit theorem, what will happen? See. But there is a disadvantage of that approach also. KCL approach, KVL approach. Because for a large and complex circuit and tedious computation is involved. If you are having a very large circuit and suppose we are having 5 meshes and 5 nodes. So we are having 5 equations. So to solve 5 equations and get 5 variables value, it's very difficult to solve. That's why these theorems are coming into the picture. Okay. So to handle the complexity, we are using circuit theorems. Is it okay? The first theorem is the superposition theorem. What is the superposition theorem we'll discuss about? First I'll tell you the superposition principle. Okay. Suppose you are going market. Your father gave you 50 rupee notes. Your mother gave you 30 rupees. Your younger sister gave you 20 rupee. And your younger brother gave you 10 rupee. You are going to the market. When you reach to the market, you open your wallet and calculating the money. How much money you have. So you will be having 50 plus 30 plus 20 plus 10. Is it right? So 100 rupee and something you have. Right? 50 plus 30 plus 20 and plus 10. 110 rupee you have. So what you are doing? You are adding the money. The money which is given by your father, your mother, your sister, your brother means the money you are getting from your family, you are just adding them and saying that you are 110 rupee in your pocket. Is it okay? This principle, you are adding the money now. You are getting the money from individual sources. You are getting the money from individual persons and now you are adding. The resultant money is the summation of all. This principle is nothing but the superposition principle. Similarly, in the electrical circuits, we are having the superposition theorem. So this superposition theorem based on the superposition principle only. The SPT says, suppose in a circuit, 2 or more than 2 independent sources are working. Means in the source or in the circuit, you are having 2 or more independent sources, means a voltage source or current source. In that particular circuit, consider one branch AB. In that particular branch, the current will flow. Suppose the current is flowing is something. So that particular current in that particular branch will be nothing but the summation of all current provided by the individual sources. Is it okay? Voltage source is providing some into that branch. Current source is providing some current into that branch. And the overall current in that branch is nothing but the summation of the currents which are provided by the individual sources. This thing is nothing but the superposition theorem. Okay, and you can see here. Wait a minute. See, the superposition principle states that the voltage across a current, an element in a linear circuit, is the algebraic sum of the voltages across that element due to each independent sources acting alone. What I am saying is, consider a circuit. Here I considered it. In this circuit, I am having one independent source, battery. Here it is. And one current source, I am considering. This branch I am taking into picture, okay. The current in this branch is suppose I. So according to the superposition theorem, this I will be nothing but the I provided by this source. I am taking V plus, this is the algebraic summation, okay. means we'll consider the direction also, plus the current provided by the source, II. This is nothing but the superposition theorem. Okay, this is the very simple here. The principle of the superposition helps us to analyze a linear circuit with more than one independent sources. More than one independent sources. Then only we can apply the superposition theorem. By calculating the contribution of each independent source separately. So in the superposition theorem, what we will do, we'll first take the contribution of voltage source. We'll find out the contribution of voltage source. Then in the second step, we'll find the contribution of the current source. In the third step, we'll add them. Algebraic summation I'm telling you. And that the resultant is nothing but the output or output current or voltage in that particular branch or element. Is it okay? Now see, what are the different steps? 2 points are given here. We consider one independent source at a time while all other independent sources are turned off. What it means, suppose first you are going to find out the contribution due to this voltage source. So you will turn off remaining sources in the circuit. Simply you will turn off the circuit. Then only individually you are going to find out. So the contribution due to V, how you can find out? You can find out by turn off all other independent sources working in the circuit. So this is the first case. Now if you are having dependent sources, see sometimes dependent sources you will encounter with the dependent sources also in the circuit. So don't touch the dependent sources. I'm telling you with a diagram now. See the superposition theorem I'm telling you now. By example I'll tell you. Consider a circuit volt, 5 ohm, 5 ohm, and this is 10 ohm. Consider it like this. Current 10 ampere, and my task is to find out this current I. Okay, and the direction of this current I'm changing. I'm taking the opposite direction. Okay, for the better clarification of this, I'm taking this current to this side. Okay, by SPT we have to find out. By SPT we have to find out I. So in this example, I'll show you the steps how to find out the output by the SPT, superposition theorem. Okay, so according to the superposition theorem, first check the circuit. How many independent sources are there or dependent sources are there in the circuit. The independent sources should be more than one in the circuit. Then only we can apply the SPT. Here in this circuit, I am having two independent sources. Number one is voltage source having value 10 volt, and second is current source, and value of that source is nothing but 10 ampere. I am having two sources here. Now one by one I'll take the sources and we'll find out the response of that circuit, that sources. Okay, first I'll take in consideration the voltage source. Means I'll own the voltage source, or I can say I'll keep the voltage source, and turn off current source. This is my task. I'll keep the voltage source first. This is the very first step. I'll keep the voltage source in the circuit and I'll turn off the current source. Now here are the points of turn off the sources from the circuit. If you want to turn off the voltage source from the circuit, you will short circuit it. That particular branch will short circuit it. If you want to turn off current sources, you will make that branch open circuit. this will be open circuited. Are you getting me? Means suppose you want to remove the voltage source from the circuit, you will replace that circuit by a short circuit. But when you want to turn off the current source, you will replace this particular branch by open branch or open circuit. Here first I am taking the voltage source in consideration. Take the voltage source in consideration, 10 volt. Okay, fine. Take 5. Fine. This branch is as it is. Given 5. Here 10. Now what about this current source? I told you the current source will be replaced by open circuit always. Current source will be replaced by open circuit always. Okay. Now this I is here flowing in the circuit like this. This branch is open. Open branch means no current in the circuit. You know, in the open circuit branch there is a no current. Okay. Now come here. Now can I get the value of this I? Yes. By the KCL or Ohm's law, KVL, whatever you want, simply I'll apply 5, 5. They are connected in series. This branch is open, so there is a no branch. So that's why 5 and 5, they are in series. Is it okay to you people? If this branch 10 ohm is connected further, so we can't say 5 and 5, these are in series. But at this moment, these 5 and 5, these two resistors are in series. So the source voltage is 10 and your resistance, equivalent resistance is also 10. So you are having 1 ampere. This is, I'll give the name I1. This is I1. So by Vs, you get the current I1 and that is 1 ampere. And what is the direction of this? Yes, this is the direction. Whatever you assume, the same direction is 1 ampere. Okay. You got I1 equal to 1 ampere. Now in the second step, we'll keep the current source and we'll remove the voltage source. In the step 2, I have to erase this completely. Wait a minute. Okay, now we are in the second step, and second step says, in the second step, we'll keep the current source as it is because the voltage source part is done already. Here, we'll keep the current source and turn off voltage source. And I told you earlier how to turn off the voltage source. We'll short the circuit. First draw the circuit. This is 5, okay, fine. This is 5. This is 10 ampere. Okay, what about this voltage source? We have to short it. Short circuit means this. This is the short circuit. Now your voltage, independent voltage source is turned off. Okay. Now your task is to find out the current over here. In the direction of current, given direction is this. Is it okay? This is the given current. Now this 10 ampere current is coming. Okay. Now this 10 ampere current is getting two parallel connected branches. Two parallel connected branches. So one current will go to this side. One current will go to this side. Current division rule we can apply here. The value of this current I is nothing but the source current into opposite branch resistance, yes, opposite branch resistance, divide by summation. This is the summation, 5 plus 5. 10 will cancel out and you are getting 5 ampere. See, the direction of 5 ampere is opposite. In this case, case 2, you got I2 and your I2 is nothing but 5 ampere. Okay, now algebraic summation, the resultant. Okay, two steps are over. Now in the third, the overall current is nothing but the algebraic summation of I1 and I2. Okay. What was the direction of I1? When you solved this circuit, the direction of I1 was like this. Correct. But the direction of I2 is opposite to this. Like this. Is it okay? So if in the circuit, the I direction is already mentioned. This is the I direction. Already mentioned. So we will give the answer accordingly. We will put our answer according to this direction only. Here the resultant is the I1 is coming from up and I2 is going to up. So I1 is, you already find 1 ampere and this is opposite to it, minus 5 ampere. So you are having minus 4 ampere. What this minus means? This is upward, right? Actually this current is, suppose you are taking, see, this current, if I'll ask you, tell me the current 4 ampere, where it's going. See, from up to down I am having 1 ampere. From down to up I am having 5 ampere. So overall what is the resultant? Resultant is 4 ampere going up. This is our answer, that 4 ampere going down to up. But he already mentioned the current direction is from up to down. Means we'll tell the result is minus 4 ampere. Are you getting? Minus 4 amperes indicate, this minus 4 ampere indicates that your direction of current is not this, the direction of current is this. Is it okay to you people? This is all about the superposition theorem. Very easy. Is it? Steps to apply superposition theorem. As I told you in the example, turn off all independent sources except one source. The source which are we going into the consideration. Find the output voltage or current, whatever in the question they are asking. Due to that active source is in the KCL or KVL. Simply we have to apply KCL and KVL and we have to find out. Repeat step 1 for each of the other independent sources. Suppose we are having 3 or 4 independent sources in the circuit. So I'll repeat the process for all independent sources. And we'll get the individual response of individual sources. At the end, see, find the total contribution by adding algebraically. Means we have to keep the care of the direction also. All the contribution to the independent sources. I hope this one is clear to you. Right? Now, so this is all about the superposition theorem, friends. In the next lecture, we'll see the examples and we will see the another circuits also, circuit theorems also, like Thevenin and Norton we'll see. I hope you are enjoying the subject, you are getting your concepts clear. In the last video, in the last unit, basic concepts, we have done so many problems. Now I'm advising you, please do as many as problems you can. It will clear your doubts and you will be conceptually strong. And I told you earlier, once you are conceptually strong, you can crack the gate anytime. So friends, we'll meet in the next video lecture. Till then, take care and bye.